And the first thing I want to look at is there is a chart there that says Lesson 12 handout. Let me go ahead and share my screen with everyone. You should be able to open up the same document though. So this kind of goes back. This is going to be the last thing we're really talking about bath bombs about. And then we're kind of done with bath bombs after this. So the last question in the assessment from Tuesday basically asked you, where did the particles come from that created the gas? So for those that haven't completed the test, well, you're going to get some answers here if you're paying attention. So hopefully we all at this point realize the gas being produced was carbon dioxide. When we mix the citric acid and the baking soda together. So I have two models of citric acid. This is the big molecule right here. Baking soda, which is a smaller atom or molecule, and water. And I mix all those together and it yields. So these are called reactants. It makes, this is citric acetate, I think, citric acetate, carbon dioxide, and water. My question I have for you, and I'd like to see you answer in the Google chat, is which one of these is most likely the correct model showing the production of carbon dioxide? So what I have on this side, I have the same number of waters, I have the same number of carbon dioxides, and I have the same number of sodium citrate. That's what it is, sodium citrate, on this side. However, on this side, one has more citric acid than the other. There's 3 up here and there's 1 here. They both have 3 baking sodas and they both have 3 waters. Is it model A or model B that would create the correct output? So look at those and tell me which one you think is most correct. Just type your answer into the Google chat. Don't say it out loud. Okay, there's one answer. Only one person willing to make it up. There we go. Ryan says B. Addison says B. B, 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 B. Olivia agrees. Judd, Blake. A lot of people thinking B. Poor old A. Nobody even wants to give A a try, huh? All right, let me see here. Let me randomly pick one of you. So Ryan, how you doing today, Ryan?
Good.
So Ryan, you say B. Why do you think it's B?
I don't even know. I just don't think it's the other ones.
Okay. Olivia, why do you think it's B? Olivia. Well, she answered, but now she's not responding to me. Well, I'm glad Blake just finished his Dr. Pepper. Oh, okay. Okay, so Olivia, I asked, why do you think it's B?
Can I pick question or should I?
I'm giving her a second to type. Okay, the other model. There's only two models total. Okay, let's ask one more person. Miss Smith, why did you pick B?
From our perspective, the lamp behind you looks like your angel. The lamp head looks like the halo above your head.
Well, that is a halo. I am an angel.
Yay!
So there's a song sung by the Carpenters about me. It says, "On the day that I was born, the angels all gathered round and created." Never mind. Okay, so Kendra has changed her mind. She thought it was B, and now she's going to say A, and she says because it has more citric acid. Well, let's go back and look at the model. So if we remember this thing called the law of conservation of mass, matter cannot be created nor destroyed, only rearranged. So what that means is however much stuff I have here after a chemical reaction, which is what the black arrow is, I must have the same amount here. So if I do that, let's look at carbon. I have 1, 2, 3, 4, 5, 6. 6 times 3 is 18. 19, 20, 21 carbons on this side. And I come over here, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 carbons on this side. It can't be A. I can't make carbon disappear. If I come down and look at A, I have 6, 7, 8, 9. And over here, I have 6, 7, 8, 9 carbons. If I count my oxygens, they're all going to be the same. And if I count my hydrogens, they're all going to be the same. Whatever I start with, however many atoms I have at the start of a reaction, after the reaction occurs, I must have just as many. This is called the reactant side. This is called the product side. The number of atoms must equal each other on either side of the yield, of either side of the chemical equation. Does that make sense? So yeah, it comes back, that is a practical application of the law of conservation of mass. Matter cannot be created nor destroyed, only rearranged. So a lot of you were correct. Yes, it was B, but the thing was, most of you were just guessing. So, but now you know the reason why is because they must be equal on each side. Depending how things go in the next unit, we may end up doing what's called balancing some equations, where we'll actually take chemical reactions and make them so they're equal on each side. That's something that's actually done a lot more in 8th grade and 9th grade, but I love to introduce the concept now, just so you can kind of sink your teeth into it a little bit. Okay, so enough of that. On Tuesday, I ended the class and I put a little note into the Google Stream saying if you had available, I wanted you to acquire lemon juice, lavender, menthol, vanilla, and vinegar. 5 different things. So, did any of you manage to acquire those different items? Okay. So, what we're going to do is I want you to open up the document now that looks like, oh, actually, no, I'm sorry. First thing I want you to do, I'm going to give you about 5 minutes at most. There is an article here. This is How Do We Detect Odors? I want you to give this article a quick read. And then we'll proceed with the lab that we have. Fantastic, Elizabeth. Great, Addison, you got him. I know Blake got some. I saw him shaking his head.
I have every single one of them.
Awesome. And again, hopefully nobody went out and bought anything. You didn't need to buy anything. But they're all common items around a lot of houses too. So menthol. The menthol I use actually comes out of something called Vicks Vapor Rub. Vicks Vapor Rub is something when you're sick, you your parents or yourself, you'd rub it on your upper chest, right above your collarbone or right around your collarbone, and it helps break up congestion. And that's fine, Elizabeth. Like I said, I didn't expect everybody. No, unfortunately, it doesn't fit into what I'm supposed to teach you. But I have seen people make a liquid that glows in the dark with a highlighter and Mountain Dew. You tear a highlighter apart. You get there's like a little spongy material that's inside the highlighters. And it's best to wear gloves when you do this. You squeeze that liquid into a Mountain Dew and it kind of glows in the dark. But definitely don't drink Mountain Dew when you're done. Okay, so hopefully we should be wrapping up the reading by now. Okay, so the next document, it is labeled Lesson 13, Handout Odor, and it looks like this. It's called Odor Lab. Has 3 columns on it, and it has 4 rows, but I'm actually going to want you to get in the last row and tab over a couple times, and it'll make you a 5th row. You need 5 rows. So what you're going to do is, as we go through these, you're going to write down the substance name, and then as you smell it and or we talk about it, in case you didn't get the materials, hopefully you're familiar with what all these smell like, but you're going to write down as much information as you can here about, what the odor reminds you of, what you think about when you smell the odor, and so on like that. And then we're going to come back and talk about the 4th column, the 3rd column in just a minute. Okay, so the first one we have, if you have a lemon or if you have lemon juice, go ahead and get that one out. And you are supposed to waft or waft the odor to your nose. So in any kind of lab setting, you never want to come up to a beaker and put the item right up to your nose. It's not a good practice. So what you do is you sit here and you kind of, push the smell towards your nose. So if you don't have it, is there anybody here who has never smelled lemon? So good. It sounds like everybody has smelled lemon. Tell me what you think of when you smell lemon, or what it smells like to you. Obviously, a lemon smells like a lemon. I mean, I know that. That's kind of a no-brainer. But when you smell lemon, what do you think of?
Get in my eye.
That stings because lemons are acidic. Okay, Kendra says citrus, a strong scent. Um, Believe it or not, I think of cleaning supplies. There are some.
Those sanitizer wipes.
Yeah, a lot of them are citrus in flavor. When I was in the Navy, they used a citrus band disinfectant. So when I smell lemon, I automatically think of cleaning fluid. To me, it's kind of strong. It's a little bit pungent. That's how I would describe it. But write down all these things you can think of in that column for lemon. And what do I think of when I smell lemon? It reminds me of a summer day. For me, smells and songs are very strong reminders of past events. Um, Addison, it should be open for you to edit, but try making a copy of it if you need to. That somebody actually told me that before. You need to change the um, font color to black. I don't know why it would be in white. That's really strange. But thank you for. What's that?
It's the A.
Oh yeah. No.
No. The A was on highlighter.
Okay. Yeah.
Yeah.
Well, yeah, it's still not letting me. Oh, I knew that. That's still not letting me type though. Okay, let me. Oh, there we go. I got to do the whole thing. I'm a noob. That's what my son would call me, a noob. Okay. So going on, whoops, I don't want to be there. Going on to the next one. Looking at lavender. Now, myself, I'm using lavender bubble bath. I saw somebody said they had their mom's lavender lotion. Oh, Addison, you had lotion, and that's fine. Lavender lotion is fine. It still gives you the smell of it. So go ahead and smell the lavender. If you've never smelled lavender, I'll tell you it smells flowery. Lavender is a flower. It smells like perfume, maybe. A lot of people will wear a lavender scented body splash, or they use lavender shampoos, things like this. Lavender is known to be a relaxing odor. If you or your parents have essential oils, they'll usually use lavender as a relaxation thing. Addison, you didn't hear what part? Oh, not letting me run this. Oh, you needed to change the font color to black. You're actually writing, but it was in white, if that's what you're talking about. We could thank Blake for that. He's the man. He figured that out. So, and to me, lavender actually just, I don't know what it really reminds me of. Kind of Hobby Lobby.
I did not mean to leave.
It's okay.
And y'all are welcome.
Yeah, Olivia says she has a diffuser, turns on when you're going to sleep, because that's one of the things it does. It relaxes you. There are some teas that are embedded with lavender because it's supposed to be calming, relaxing. That smelled pretty good, Elizabeth. You're saying, Elizabeth, your lavender smells like nail polish remover? Okay. Oh, that's good. Thank you, Will. Appreciate the help there. I'm really good with a lot of Microsoft products. I'm still there's a few shortcuts that I'm not familiar with in Google. I'm slowly getting there. I'm an old dog. It takes time. Okay, the next one for me is a dark brown liquid. This is vanilla. Love the smell of vanilla. What's that, Blake? Mine is imitation vanilla, but it could be vanilla, vanilla extract, or real vanilla. And to me, vanilla, raw vanilla, almost smells like a medicine. It, but it reminds me of my coffee, and that's because my coffee is caramel vanilla. I drink a little bit of coffee with a lot of caramel vanilla creamer in it. But yeah, I mean, it makes me think of ice cream. I love vanilla ice cream. It's my favorite. Addison says cookies. My wife has been making a lot of, it's called Amish friendship bread, and she makes it with vanilla in it. So, yeah, a lot of baking, stuff like that. Reminds Elizabeth of happiness. That's good. Keep lots of vanilla around then, Elizabeth. Okay. Now, the least two favorite ones, a clear liquid. This is vinegar. Very kind of stings a little bit when you smell it. It's very sharp, very bitter kind of smell. Um, to me, it makes me think of pickles, which I hate. I despise pickles. Makes me think of pickles. But it reminds me the most of Easter eggs. Have you guys ever used vinegar when you're making Easter eggs?
Once before. We used it when we were dying for blood and things.
Yeah, usually you get a cup of vinegar, you'll drop your colored tablet in there, and you set the eggs in there. But yeah, I mean that's the smell that it brings back most is sitting around making Easter eggs with my daughter and my son. But something that's really neat about vinegar and eggs, and some of you may have done this before, if you get a cup of vinegar and you put an egg in there and let the egg sit in there for 3 or 4 days, you'll make you make what's called an invisible egg. You'll dissolve the shell of the egg, and then you'll be able to see right into the egg without it having a shell. It won't spread everywhere unless you poke it. But yeah, it's kind of neat. So, and the last one in my case is it's a gel that's in there because mine is Vicks Vapor Rub, and this is the menthol. You may be more familiar with menthol from cough drops. Cough drops use it. Yeah, Addison went right to the source. Vicks Vapor Rub right there. Yeah, actually, that's the same one I have. That's in the Equate version of it. Mine's across the room though. But it smells. Some people say it smells like icy hot. Something you rub on sore muscles. Cough drops. It almost has like a mint smell to it. That's what the menthol is. It's kind of like a mint, but it's a very powerful mint smell. But yeah, kind of interesting. So the last part, okay, Ray says it reminds me of a doc. Well, it's probably because, Ray, if it reminds you, I'm sorry, I don't know why I'm calling you Ray, Raymond, Ryan. I'm sorry, Ryan. Forgive me, please. Yeah, it might remind you of a doctor's office because normally when you'd use things like Vicks Vapor Rub or Vicks inhalers or stuff like that, you're sick. And I have smelled that smell many times at a doctor's office. So, it's very possible. I don't know if you guys have these things called humidifiers. They're a square thing, probably about a foot by a foot. You fill them up with water and you stick this thing inside of it and you plug it in and steam comes out. Well, one of the things that you do when you're sick is you get those and you'll take the Vicks Vapor Rub like Addison had, and you'll take that gel and you'll stick it in a little container right by where the air comes out, and it will put that smell all through your room. And it really does help when you breathe to get rid of your congestion. Olivia said, you rub it on your chest, you rub it on the upper part of your chest, and it does. That menthol sinks down into your skin, and you better believe it. It will clear you up pretty good. They actually even have these little tubes of Vicks vapor, and you can put it basically in your nose, and you hold one nose and you just kind of breathe in, and that will clean out your sinuses as well. Yep, very true, Olivia. Okay, so now the last part of this last column, and this is pretty much all we're going to have for the day, is, let me see, was I still sharing my screen? Or had I stopped sharing my screen? Yes, I am still sharing. Okay, so it asks you to talk about the molecules. The actual question was, where's my computer's lagging up on me. What do you notice about the related molecular models? So what I want you to do is, the other document that's on this list says molecular models of different substances. And you'll notice that we are looking at three main atoms: hydrogen, carbon, and oxygen. So you come down here and you have vinegar. It shows you the model of vinegar. Limonene, which is the molecule that you smell from lemons. Vanillin, which is the molecule that you smell from vanilla. Menthol, which is obviously the molecule of menthol, but it's also what you're smelling. And then linalool and lanolinic acetate. Both these combine help you smell lavender, because if you remember, if you read that far in the reading, it takes 7 different molecules for you to actually smell lavender. And these are the 2 big ones that you need to have. So what I'm going to want you to do is, I'm going to give you a demonstration on limonene, because that was the first one we did. So it asks you to look at the molecule and basically tell me about it. When I look at limonene, the first thing that I notice is limonene has no oxygen in it. If I look at all the other molecules, they all have at least one oxygen. Limonene has none. Carbon is in the very center of it, and it's surrounded by hydrogen, and it's still a pretty big molecule. So that's all I'd write for it: no oxygen, big molecule, carbon surrounded by hydrogen. And I want you to go through and do that for each one of the substances we just went through. Does that make sense? And that is the assignment for today. Now, I'm stopping the recording right now.